Okay, so today we're looking at geometric sequences. So our learning intention is again the knowledge in calculating the common ratio and the recurrence relation of a geometric sequence. So we'll be successful if we can calculate the common ratio and establish a recurrence relation of the geometric sequence. So some information. So geometric sequence can be found by the following term. Basically, it's found by multiplying the previous term by a constant. So let's do some example. Let's say I start with 5. And what I'm going to do, I'm going to multiply 5 by 2. So 5 times 2 is 10. Times that by 2 again is 20. Times that by 2 is 40. Times that by 2 is 80. Okay, so the previous term can be found by multiplying it by a constant. This constant is called the common ratio, and we denote it by the letter R. And technically we can find R by basically taking the term and dividing it by the previous term. Okay, so R is equal to Tn divided by Tn minus 1, the previous term. So the sequence 3, 6, 12, 24 has A as the first term and R of 2. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. Okay, so think of it. So the first term, T1, this one here, right, is A. I find the second term, T2, by multiplying 3 by 2, by R. 3 times 2 is 6. I then find the third term by multiplying this term, which is technically AR, by R again. So I actually get AR squared. And I get the fourth term by multiplying the third term, which is AR squared, by R to become AR cubed. So to find the nth term of a geometric sequence, so T to the nth term is AR to the power of n minus 1. And this formula is on our formula sheet. So Tn is the first term multiplied by the common ratio to the power of n minus 1. Let us do some examples. All right, we want to find if each of these sequences is a geometric sequence. Okay, so to do so, we need to go T2 divided by T1, and we need to check that that is equal to T3 divided by T2. Okay, and that should give us R. So let's check. So in this case, T2 is 20. 20 over 5 equals 4. Now T3 on T2 is 60 over 20, which equals 3. So therefore, this is not a geometric sequence, as there is no common ratio. Okay, let's try this one. So T2 over T1 is 3 over negative 4, which is negative 3/4. Okay, let's try then T3 over T2. So negative 2 1/4 divided by 3, if you plug that into the calculator, you will also get negative 3/4. So this is a geometric sequence. As it has a common ratio of negative 3/4. Once again, let's do this one. So we've got T2 over T1. So 1.71 divided by 5.7. If you plug that into the calculator, you'll get 0.3, or 3 on 10. Right? So T3 divided by T2, 0.513 divided by 1.71. If you plug that in the calculator, you also get 0.3. Okay, so as these are the same, this is a geometric sequence, as it has a common ratio of 0.3. Alright, let's do these examples. We want to find the prime numeral in each of the geometric sequence. Okay, so if this is a geometric sequence, it will have a common ratio. So that means that T2 over T1 is equal to T3 over T2. Yeah, that will give a common ratio of R. So plugging in what we know, we've got 28 over 4 is equal to X over 28. Okay, because we have an equal sign, we could cross multiply, so this becomes 28 squared equals 4x. So x is equal to 28 squared over 4. If you plug that into your calculator, 28 divided by 4 is x is 196. Okay, and you should be able to check that. So the common ratio is 7, so 4 times 7 is 28, 28 times 7 is 196. Beautiful. Using the same technique, T2 over T1 is equal to T3 over T2. So A divided by 2 is equal to 72 divided by A. Cross multiplying, we get A squared is equal to 72 times 2, which is 144. Now, if you take the square root of 144, that was going to give you plus or minus 12. Okay, so here we've got basically this ratio of multiplying it by either positive or minus 6. So you do actually get two opportunities. Like if you had 2 times negative 6, you'd get negative 12. Times by negative 6 again, you get positive 72. And obviously if you times it with a positive 6, you get the same, but all positive numbers. So these types of questions definitely has two solutions. Alright, 3 equals x minus 4 over 15, 3x minus 4 over 15. So T2 over T1 is equal to T3 on T2. So x minus 4 over 3 is equal to 15 over x minus 4. Cross multiplying, we get x minus 4 all squared is equal to 45. Beautiful. To get rid of the square, we take the square root, so that's going to be plus or minus the square root of 45. So x is equal to 4 plus or minus the square root of 45. Okay. Here we go. So we want to now find the sixth sequence of this sequence. 1, 5, negative 1, 5, negative 25. Okay, and what we're going to use is we're going to use our formula of Tn is equal to A R n minus 1. So in this question, A is negative 1. The ratio is 5 over negative 1, which is negative 5. Okay, and n is 6. So T6, A is negative 1. My R is negative 5 to the power of 6 minus 1. So negative 1, negative 5 to the power of 5. If you plug that into the calculator, you will get 3,125. Alright, so here, 1, 2, 4, A is 1, R is 2 over 1, which is 2, and N is 9. So T9 is equal to 1. That's A. R is 2. N is 9 minus 1. So that's 1 to the power times 2 to the power of 8. If you plug that into your calculator, you will get 256. Okay. So in this situation, A would be a quarter. The ratio is 1/8 divided by a quarter, which is R half, and N equals to 20. So T of 20 is A, which is a quarter, multiplied by R to the power of N minus 1. So that's a quarter to the power, a half to the power of 19. If you plug that into your calculator, you get 1 over 2,097,152. Okay. Alright, so we want to find which term of the sequence is equal to 7,776 if we have this sequence, 6, 36, 216. Okay. So remember that we have the formula Tn is equal to A R n minus 1. So we know what A is. We know that's 6. We know what R is, because that's 36 divided by 6, which is 6. We don't know what N is. Okay, but we know it's equal to 7,776. What I'm going to do first is divide this number by 6. So 7,776 divided by 6 gives me 1,296. And that's 6 to the power of n minus 6. So what 6 I was dividing by was this one here. Okay, there are two methods that you could possibly do from this stage. We could do basically what we've got is we want to make this number in terms of 6 to the power of something. Alright, so I'll go 1,000, so 6 to the power, and I can guess 4, right? Oh, perfect. 6 to the power of 4 is equal to 6n minus 1. As they've got the same base, that means that 4 is equal to n minus 1. Alright, so therefore n equals 5. So that's method 1. That's method, which is kind of the trial and error. Now method 2 is using a different, so method 2 is using logs. So what we have is if I take the log 10 of both sides, yep, what it means is that I can bring this n minus 1 in front. I can bring that power down by taking the log of that. Yep. And now I could divide this whole thing by log 10 of 6. So log 10 of that divided by log 6 will give me n minus 1. Now if I plug that into the calculator, log 1,296 over log 6, that's going to give me 4 equals n minus 1. Right? And then obviously n equals 5. Right? This method is a little bit faster, especially if we've got trickier numbers. Otherwise you can use trial and error. Yep, so n is equal to 5. Okay, and that's it. So which term of the sequence is equal to, yep, so the fifth term. Therefore, the fifth term of 6, 36, 216 is equal to 7,776. Okay, excellent. Have a good day.